Good afternoon, at least in Europe, and welcome to the DEKRA Energy Storage Systems webinar, in which we like to introduce you to the new standard IEC 62933-5-2. And this is an AND product standard, and it is focused on the safety of battery-powered energy storage systems. So my name is Gert-Jan van der Haven. I am the account responsible for energy storage systems within DEKRA. And I will be joined by Henk Kormelink, and he is our product specialist on industrial electrical products. This webinar will take about 1 hour, and we will only handle the highlights of the standard, and we will have 2 interviews at the end. As we are a bit limited by time, if you have any technical questions, please put them in the Q&A, and we will come back either at the end of this webinar or by email follow-up. And good to know that this webinar will be recorded and the presentation can be shared afterwards. In addition, we'd like to get to know that you as a participant, and we'd like to ask you as well a few questions. Therefore, we operate the Klaxoon platform. So over here is the Klaxoon platform. You can either go to the website www.klaxoon.com and use an access code, but even more easier, in the meeting chat, we have a link directly to Klaxoon. If you click on that, you can log in on your mobile device or your second screen, and then the questions will be presented during the webinar. So I give you a short time to log in. And let's try out for the first time, and this question will remain on the platform until the next question will arise. So if you are a bit in the if it costs you time, then you can answer it a bit later. The first question is, who as an audience do you represent? Is that either a manufacturer of energy storage systems, either components or end systems? Are you an integrator, or are you a third party, or are you another person attending this webinar? So this webinar is organized by the Industrial Safety Cluster of DEKRA Product Testing and Certification, and we usually abbreviate that to DEKRA PTC, and we are part of the global DEKRA group. And this is a multidisciplinary in all its activities, but it all relates to safety at home, safety at work, and safety on the road. And from our PTC laboratories all across the globe, but also from our customer sites, we test and certify, being an accredited body for many product groups, ranging from household appliances to electric vehicles, but also electrical products used in the energy distribution sector. So as an industrial safety group, we are well equipped, being a multidisciplinary team, and we participate to projects all across the globe mainly also on decarbonization of the electrical grid. At the end, the overall goal is that all the equipment is functional, but at the end also safe and reliable on the long term. And that's why our customers appreciate this. If you look to the product development chain, a TIC company, a test, inspection and certification company, like DEKRA, is functional along the product chain, being the neutral party who is testing, inspecting, and certifying. We provide the technical and the compliance services. So that was the main advertising. Let's go to the topic of today. which is the energy storage market. As you know, we are globally active on decarbonization of the electrical grid, and that is because the consumption is growing a lot year on year. On the right hand side, there's a slide which describes that at least in Europe, so the EU and the UK, it is expected that the 1.8% growth will be forecasted over coming years in consumption. And well, you know how it works in emerging markets there, the increase will be even higher. At the end, we work on sustainable growth. And energy storage systems do play a role in a more smart grid strategy. Energy storage systems, we can differentiate between two areas, and I would call it, first of all, a centralized approach, which is managed by grid operators, and it's working with high standards. At the other end, we also have a residential approach or a consumer approach, which I would call decentralized, and consumers or small businesses would be the end customer for this. At the end, it is estimated that over the coming 10 years, about 425 billion euros is needed to upgrade the electrical grid in Europe. I'll give you a few examples how energy storage systems, in case you are not familiar with those systems, how diversified they are. It's ranging from large-scale holes with batteries to, well, EV charging stations with backup battery power. And the decentralized approach would mean that there is also the famous home storage panels you could put on your wall and connect to your solar power roof. Second poll question. What is your main market application? And you will find the answers also on Clock soon. So please select one, and then we better get to know you. A short overview on the industry stakeholders. From the demand side, we have the network operators, either publicly owned or privately owned. There are smaller grids, like industry-driven grids or microgrids, and also the trading channels, which are rising now. On the supply side, components, either batteries, power electronics, enclosures, or the entire system development. And third-party contribution comes from either authorities or insurance or test labs like DEKRA. If you're not involved with development of energy storage systems, there's always a lot of focus on the battery side of systems, and there are a lot of standards involved with batteries. If you're producing a system out of this, it means the addition of a lot of components, and those components need to be certified and tested as well at the entire system level. So concluding with the safety challenge, as you saw, there's a wide array of products. There's a wide array of installation requirements. There's also a wide array of companies involved. The big companies are like Fluence or AES or ABB, but also smaller startup companies or SMEs involved. So there's a huge variety. So that's why standardization is of key importance. Also to prevent impact, prevent incidents, and well, safety concerns. We often hear about fires. They come in the newspapers, but fires are always a last step before some things have gone wrong before a fire can actually start. That can be a voltage problem or an environmental issue like earthquakes or floodings. At the end, the overall goal is that we gain trust for long-term reliability and maintainability of these energy storage systems. I'd like to hand over the presentation to my colleague, Henk Kormelink, but before that, there's a last poll question. And the question is if you are familiar with ESS-related standards, either the IEC or the UL standards or national codes, or none of them. Henk, over to you.
Okay. Thank you, Gert-Jan. Yeah, from this slide onwards, I would like to take you in roughly 20 minutes through the technical part of the IEC 62933-5-2 standard for battery storage systems. I will first show you, let me see if it works. I will first show you some ESS applications, after which we will on a high level go through the aspects of validating an ESS product. But now, why?
Now I clicked.
Yeah, okay, yeah. So in this first slide, we see examples of electrical storage system applications which could fall under the IEC 62933-5-2 standard. For example, we see ESS systems that can be used to store inexpensive energy and supply it when costs are higher. For example, on the right-hand down side, you see it for residential applications. But we also can use ESS systems to store excess energy production that would otherwise be curtailed, like for example, energy from renewable sources like wind and solar, which you see on the left-hand side. As the electrical grid is dimensioned for power capacity needs, an ESS can also defer investments in a grid upgrade for a system operator. But it can also reduce the need to purchase extra capacity from the energy supplier by using, for example, a peak shaving application. Generally, ESS systems can help to stabilize the transmission and distribution as well as the power quality. An interesting topic I saw this week was that I read a message that due to the solar eclipse that we have today in Northwest Europe, the transmission system operator has requested some gas-fired power plants to be in a standby mode to compensate for the possible loss in solar power from PV systems. As it is a sunny day today and we have many solar systems installed in the Netherlands, the eclipse was expected to cause a sudden drop in solar supply energy. So I expected in the near future also these type of products could be used to cope with these kind of situations. No,
I think I will click through it. Thanks.
Okay. Yeah. So the IEC 62933-5-2 describes the requirements for battery type of storage systems. The -5-1 is for it gives the general requirements, and the 5-2 is for battery type of storage systems. And as we can imagine, the requirements for residential cases or industrial cases result in different requirements on the product. The energy storage capacity is different. The environment is different. It could be indoor or outdoor. The users are different, laymen, or you are a trained staff. But also the function of the product may be different, as we saw in the earlier slide. In this picture, you see monitoring and control interfaces that will allow users to manage the energy in line with the expected function that they have configured, like when energy should be taken from the batteries or when you would like to take it from the grid. If you now look at the general architecture of these ESS products, you see that you see similar subsystems on a higher level. I'll go to the next. Yeah. In this slide, you see the main subsystems of a battery energy storage system. And you also see the standards which are applicable for all these different parts. The core is the energy storage in the middle. And further we see more to the left, the power conversion subsystem. And to the right, the control, auxiliary and protection subsystems. The control system monitors and controls the functions of the total product. And the auxiliary circuits subsystems cover, for example, heating, cooling, or ventilation type of systems. As the standard clearly states that all components that you use to build a product like this need to comply to their own product standard, you can imagine that you have to look at a lot of different type of standards. The good thing, though, is that DEKRA has many experiences in many of these different standards. On the right-hand side, on the right-hand side, you also see another standard as covering life cycle management requirements. This is also part of the same standard. So you have to document a maintenance plan, write a preventive maintenance plan. You have to describe how you train your people, etc. This may be different per country, and what you see here is the standard for the Netherlands. So in this slide, you see how you can validate an ESS product according to the standard. You need to perform a risk analysis for all these different areas. If you look at the different hazards that may apply to this product, as shown in this slide, it is clear that it may be a big challenge to find all the necessary competences. For a proper risk analysis, all these potential hazards need to be addressed. Explosion hazards, fire hazards, EMC, or even cybersecurity are areas where DEKRA departments can provide their expertise. And as we have seen in the application overview slide, the ESS systems can play an important role in the electrical infrastructure. And now, if you recall the cyber attack that we recently had in the US on the Colonial Pipeline, you can imagine what the impact is if cyber attacks are taking place on an electrical infrastructure like we just saw. Now we go to the next slide, and that gives a polling question for you. In case you are involved in the development or manufacturing of these type of products, it would be interesting for us to know in which area DEKRA could help you in validating these type of products. It could be on a system level or maybe also on a subsystem level, like a battery management system.
I think we have a different poll question. This is concerning the performance testing. The question is, do you have a particular key interest in all performance tests, the battery testing, the electrical, or the fire side testing? And the other will come later. So we are now on the slide of the electrical energy storage system testing aspect.
Okay, I'm a little bit confused now, so
you can see the slide number 19.
Slide number 19, yeah, okay, I will continue with here. Here we see on a high level how we validate an electrical storage system. It all starts with a risk analysis. which can be performed according to different standardized methods. It could be a failure mode effect analysis, or a fault tree analysis, or a hazard and operability analysis. These are different standards that could be used to do this analysis. The outcome of the analysis will show how much, if the reduction measures that you took are sufficient for the type of product that you are developing. And the outcome of this risk analysis could be that you have to do some testing. So on the right-hand side, you see different kinds of areas where you may have to perform some testing. If you look at the electrical area, you may have to do some short circuit testing, dielectric verifications, check the earthing and bonding test, and also a special test for storage systems, anti-islanding testing. That's the case where the grid is down and the storage system may provide power to the grid. This could cause safety situations which you do not like to see. So you really need to do these type of tests to make sure that the response of your product is according to the function it has. Further, you also see in the list EMC testing. EMC testing is also an interesting topic because we know that power conversion systems usually generate a lot of disturbances. And these disturbances may influence the behavior of other components in the product. So therefore, this is an important topic that needs to be addressed in the risk analysis. And the last bullet, for example, where you talk about communication, if we look at the type of systems that could be manufactured, they can be small or they can be very big. And it's very important that there is a good internal communication to make sure that you handle problems in the right manner. But it's also important that, for example, if a system is down, you're still able to communicate with the product. So these are different type of tests that you may have to perform on a product like this. So now if we go to the next slide, we see on a high level the main steps that you usually need to take. And like we discussed, the risk analysis, which could be part of a functional safety, which could include a functional safety verification, is the first step that you need to do. Then depending on that verification, you may have to do some testing. This type of testing could be done in your own manufacturer's lab, or it could also be performed in an independent laboratory or even in the DEKRA laboratories. As some of you may know, we have very nice facilities, for example, for doing EMC testing or testing big industrial products. But after these type of tests have been performed, we also need to do, before you deliver the product, you need to do a factory acceptance test. And in the factory acceptance test, you do some additional verifications. You check, for example, if the product is built according to the specification with the right components. You do some verifications for the protection system by simulating the behavior and checking if everything works according to your spec. And then finally, we also have a site acceptance test that you need to do the moment you install the complete picture, the complete product on site. Here, you may have to look at other aspects, because if it's a big system, probably this is the first time you make you connect the cooling system together with the other subsystems. Also here, it may be that you may have to involve other people like local inspectors or fire brigade officials to get a final approval of the system. So depending on the complexity of the system, it could be that you can do everything on one location, like for example in the case of residential. But if it's a complex product, you may have to take these steps in smaller steps and where you focus on validating subsystems and where you only at the end on site can do the final validation. So now we get to another polling question. Now it would be interesting for us to see what kind of services you are interested in from a test house, like an independent party like DEKRA. This is now more on a higher level, not so much detailed, and related to the previous slide. So finally, I would like to go through some of the standards that we use for electrical storage systems. We have many standards for the IEC standard. The one that we have been discussing was the IEC 62933-5-2 for the battery type of systems. This is a standard that describes the additional requirements for the battery type of variant. The general requirements, they are specified in the 5-1. In this list of standards, you also see, for example, part 2-1. And part 2-1 is an interesting one, but it describes the test methods to determine and measure your product characteristics, like the energy capacity, the round trip efficiency. And those are not the topics that we look at when we test according to part 5-2. Of course, they may be input to the verification to know, okay, what is the worst case situation that may apply to the type of product, but it's not the testing that is mandatory to be performed according to the 5-2. In this overview, we also see that these are not all international standards. There are also some technical specifications. The role of this technical specification is basically the same as an international standard. So it is also normative in nature, but the fact that it's a technical specification indicates that this document has not reached consensus on all levels, because maybe it is seen as a little bit too premature to make it an international standard. But it still describes very clearly what the status is today. And basically, it also indicates that this is still an area where a lot of developments are ongoing, because when these standards become an international standard, people most likely will have the feeling that it will cover whatever it needs to cover. So it may, the next editions most likely will give more information in those specific areas. So if we now go to the last slide is related to the standards that we see in the US. There's basically one standard mentioned all the time, that's the UL 9540. If you go through this standard, you will see that the approach of validating a system is more or less very identical to the way it is done within the IEC. There are of course some differences, but the approach is very similar. Additional to that, it's also clear that for systems that you need to install in the US, you have to comply to the NFPA 855. That's a national code that is written specifically for energy storage systems. But the way the market works in the US, it may be that you also have to comply to other national, state, or local installation codes. So this is roughly on the technical side what I wanted to present to you. So I would like to give back the floor to Gert-Jan. Thank you.
Okay, thank you very much. If you can give me control on the slides.
Yeah.
We want to we'd like to add some interviews with some two other experts on the ESS topic. And first of all, we are joined by Maarten Mooij. Maarten Mooij, he is the product certification manager for Koolen Industries Solar. It's a Dutch company involved with energy storage development, but better to explain that yourself, Maarten.
Yes, Gert-Jan, thank you very much, and thank you for having me as a guest speaker in your webinar. You're correct, and the Koolen Industries group is more or less investing in a lot of companies who are dealing with the energy transition, not only for energy storage, but also the production of energy, transportation of energy, and also the combination of all these factors together to enable the energy transition.
If we're talking about this kind of standard, is that something which is in particular demand for your customers?
Yes, what we see is there are the requests are more and more coming, and the standard is relatively new. And so it means that not everybody is asking for it. We still face some client requests who are requesting also different types of standards. But more important, at the moment that we are talking with the client, we are being faced with many different standards, all because most of the clients and authorities are not aware of the standards there are. So you get a full list with maybe 20 different types of standards that should be taken in account. Some of them are not applicable, other ones are very applicable. So you can imagine that as a manufacturer for energy storage systems, we are very happy with this kinds of product standards which there are.
At the end, yeah. At the end, would this replace the let's say existing standards or standards on local level which are in development?
Not yet. What this standard does for us is complement our risk analysis. As Henk told, it combines all used certified components to assess it as a whole. For the major components, there are reference made to standards covering also components of battery energy storage systems to ensure our proper safety. So it will not replace all other standards, but it attempts to combine other standards. Next to it, to this, we have other standards and regulations that will remain applicable. Think about the upcoming PGS 37A, which is released in Q4 of this year, and which is at least as a on local level in the Netherlands will be mandatory and most likely be required by law. And within the PGS 37A, there will be a reference made towards this standard as part of your risk assessment.
So this
it does not say this will be mandatory by law, but it will make a reference that you should comply with safety standards such as the IEC 62933-5-2. And another example is also important for us is the application, but also the location. Where we see, for example, the marine industry, where these systems are not particularly used as energy storage as well as a propulsion for ships. And in that area, there are classification societies like DNV, Lloyd's Register, ABS, Bureau Veritas, and they have also their own requirements for these kinds of systems. So you see that this standard does complement our risk analysis, but still we are also relying on many different types of standards and requirements from authorities in order to have a product released.
So from your own position, it is important, I guess, that you invest as a company yourself also in this kind of knowledge.
Definitely, yeah. This knowledge is we are not there with a simple product standard, and this is why there's a whole series of 62933, which helps us quite a lot. But in the end, these are standards and they can form a part of our total risk analysis.
Okay. How would it be difficult to comply as a system manufacturer to this standard?
Yes and no, because we are a manufacturer, a lot of it is covered by the risk analysis. But the difficulty is also a bit determined and related to the knowledge and experience of the notified bodies. Extensive standards like this one requires a lot of knowledge on many aspects, which are both from the manufacturer and the assessor. And this can make the process of approval difficult. Not only difficult, but also time consuming and possibly expensive. So we do see that because of all the requirements and reference to other standards, the amount of assessments can cause this assessment for this standard to take a long time and probably high costs. For some systems which are maybe tailor-made, or there's only one model, those kinds of costs might not be very efficient for the manufacturer to do. One of the major aspects in this standard is so-called propagation tests. There's also a reference to the UL 9540. It's a big test, costing a lot of money, a lot of time, a lot of people which are being involved. And what we also see in this standard is there is a lot of room for discussion and interpretation. So there are requirements, for example, about vibration requirements, but they are not well defined. So it's always, let's say, a compromise between the assessor, between the manufacturer and the approval authority, which is wants to buy the system.
So this IEC standard is not a checklist.
It helps. It helps as a checklist to gain confidence in the market, definitely, but only compliance with the standard will not be sufficient.
So my last question. This market, well, seems to be dominated by battery-powered energy storage systems. How do you see alternative power sources?
Yes, well, this I put in a small overview for you, which is in the presentation, which I think people can see at the moment. So as you can see, Koolen Industries are participating in many aspects of energy storage systems. So not only battery-powered, but also, for example, thermal energy storage and the production and storage of ammonia or hydrogen. And they are all related to each other. If I go through it, you can buy clean electricity. We have wind and solar energy. Those are all placed on the grid. From this grid, the excessive amount of energy can be stored in what we call the electrolyzer, which is a project from Proton Ventures, which is battolyzer. It charges a nickel iron battery, and when it's charged, it produces hydrogen. This was in the past not very beneficial for this type of product, but now it is, because this gives us A, room to store energy, and B, to produce hydrogen. Hydrogen can be on itself then again be used for either seasonal storage of energy, but also to make ammonia. Ammonia on itself is also very good for to use as a fertilizer or to sell ammonia, but also again to store energy, and it can again be cracked and purified back to let's say energy for fuel cells. Those can also be again stored in battery systems, flow batteries or lithium iron phosphate or other types of battery energy storage. On the right top side, you see the PVT, Geo, and Rio. Those are all basically based on industrial heat, which is produced, but it is lost. But it can also be captured in a thermal energy storage system. So basically, the heat is transferred, put in a let's say the heat is being stored in a energy storage system, and can be reused later on to preheat other processes within the factory. So this type of energy doesn't go to waste, and also reduces the electricity necessary from, for example, from the grid. So you see all these items are related to each other. So we are not talking only about batteries, but we're talking about many different types of storage of energy and the reuse of this energy and to place it where it's necessary. One of the key factors in this is also how are you going to control all these types of energy storage system with the grid and with the users or end users in this total system, let's say. And this is where, for example, software, but also the cybersecurity is coming forth, which can also be evaluated. So it's not only battery energy storage system. It helps. It has their risks, but on other fields we also see the need to store different types of energy, to capture it, store it for maybe a very large period of time or maybe short periods of time, and reuse all the energy that we have in order to build a sustainable and efficient system.
Okay. Thank you, Maarten, for this overview and for, let's say, an outlook how the ecosystem for energy storage would maybe look like in 10, 15 years. We don't know, but at least this approach is very, very interesting.
Yes.
So our second interviewee would be Mr. Beat Kreuter. Mr. Kreuter, are you on the line?
Yes, I'm here.
You're the Director of Global Operations for the DEKRA, Product Testing and Certification. In general, what would you recommend to, let's say, producers, companies who have early energy storage system ambitions concerning certification in general? Let's start with an open question.
Well, I guess what Maarten mentioned already just before, I believe that that new standard, the 62933, which again is relatively new, is probably one of the perfect standards to really take into account all, let's say, potential or possible aspects of hazards. I think also Henk indicated that very nicely on his presentation, what type of hazards you might expect when you let's say, produce energy storage system, not only, of course, producing, also using, or when you are responsible for example, maintenance. So I think 62933 in many aspects will simplify. I do not call it now the certification process, because certification, of course, is a different aspect, but at least having maybe the confidence that the system has been designed in the, let's say, following state of the art. Whether you have to do a kind of like a certification on that standard or based on that standard, I think that still is actually left to the markets. In certain markets, you will have to do that because those markets have mandatory certification requirements. In other markets, you might not really need to do a certification. Maybe a self-declaration is sufficient. But what I can recommend, and I think we certainly all work towards to that, is to have a kind of like an international certification. So basically, the industry is working towards bringing that standard into the IEC EE scheme, which is kind of like international certification. So those economies which do have mandatory certification, they may make use of that, and those where you don't have mandatory certification, there you might just simply show it as compliance with a standard.
So as an, let's say, early stage company and also on early stage standardization, why should I apply for that as a manufacturer? What benefit does that have for me?
Yeah, I think again, certainly pointing out to what Henk mentioned, that standard, it is not a checklist, it is a standard, but it is a standard which basically pinpoints the potential hazards. And during your, let's say, design process, but also during the testing, of course, you have to make sure that you appropriately address those hazards. So the chances that you have a product which is indeed safe and to place it on the market are relatively high, or far higher than using any kind of standards or multiple standards which still do not specifically address the potential hazards of energy storage system. In this case, of course, since we were talking about battery-based energy storage system, let's say everything what is then based on batteries.
Okay. So if I have followed this IEC standard as a company, would this be, let's say, can I sell my products globally? Is it globally valid?
It's an international standard which has been published. Those, let's say, countries which adhere to international standards and which also will, let's say, use that quoted standard as a national standards, there you will be able to sell it. Now, of course, we know that in certain economies, just North America as one example, they are not necessarily following the IEC standard, so there you certainly will still have to be obliged to fulfill, for example, the UL requirements, the NFPA requirements. But again, I would say it's an IEC standard, it's an international standard, and I would say 80–90% of the economies are going to adopt that standard in the long term.
Okay. And what is the role of TIC companies, so testing, inspection, and certification bodies, like DEKRA or other equivalent companies? Could we provide a one-stop shop solution?
In theory, yes, we can do that. So again, if for example, there is a certain economy which does have mandated, let's say, the 62933 as a national standard, so that means energy storage system battery-based. If you talk about the -5, -2 need to comply, then definitely this is what we can do. So that also means we can actually support customers on all aspects of that standard, and which includes, of course, aspects like safety, aspects like EMC, cybersecurity, functional safety. I think Henk mentioned all those hazards already, and this is something what we definitely will be able to support.
Okay. Also, if the product has its approval, is commissioned, what should be happening after that?
That again is actually to pretty much left to the national codes. What is clear and what is also the aim of the standard is to make sure that these products are safe throughout their life cycle. So the standard is not just purely looking at the type testing, but it also has requirements throughout the life cycle of the product, which includes maintenance, but also the decommissioning. What needs to be done once the system is installed? I think that is really something which is depending on national codes, but you can imagine that you are going to have a lot of safety systems inside such an energy storage system. It's also required based on -5, -2. And of course, there will be an obligation to test those safety systems frequently to make sure that they are still operating. And I think experiences from past incidents with regards to energy storage system, of course, show clearly that there is a need to do that, just to make sure that all the safety systems which are integrated are still operational after some years.
Okay. Is there anything else you want to say as a concluding remark, or did we cover everything?
Yeah, no. Do you have any particular question?
Okay.
I mean, what I can clearly say as a concluding remark is I see tremendous opportunities with that standard, and I think also Maarten pointed it out. So finally, you have a kind of like an overarching standard for energy storage systems. In the past, you probably had to deal with virtually hundreds of standards, partially national standards, partially even regional codes or standards. You had to deal with multiple, say, battery standards, with multiple standards for the components. To some degree, you still have to do that, because I think also here, Henk pointed it out, that the individual components, of course, have their component standards. But overall, I'm convinced that 62933, especially -5, -2 for energy storage, battery-based energy storage system, will simplify the work for manufacturers tremendously to get their products ready for the global market.
All right. Thank you very much for your contribution, and we will look if there are any questions left. Or do we have a poll question? 1 second.
I do have a short question, Gert-Jan, for Beat about this standard. Beat, at the moment, this standard is not yet falling under any of the conformity assessment schemes of IEC. Do you expect that as a notified body or a national certification body that you will request this, or do you think the standard will not be taken in the conformity assessment scheme?
We do believe that this standard is going to be added to the IEC EE scheme. There were initial discussions within the strategy team of the IEC, but typically there needs to be a kind today to make this, let's say, be more efficient. There needs to be a kind like a market analysis before you are going to add something new, because in fact it's not just a new standard. It's also a new type of product category within the IEC scheme. Discussions were here whether this can be added to the category batteries, but as a matter of fact, it's not really a battery, it's a system, it's an energy storage system. So, but I'm actually convinced that it's going to be added to the IEC EE scheme.
And you also expect to be in the EE scheme or in the scheme for renewable energies, perhaps?
It could be that at the end it's going to be in renewable energy in that scheme, but I don't think so, because it's more typically an electrical product where you have aspects like safety, you have aspects like EMC, cybersecurity. So that's why it is more likely going to be inside the traditional EE scheme rather than the renewable. But I would not be able to exclude that it is not suddenly showing up in the renewable scheme.
Okay, thank you.
Well, I see we do not have any questions in the Q&A thus far. One did come, but the question is I cannot see it. So maybe our marketing can explain the question. Okay, does the IEC 62933 address second life battery storage? I think this is a very crucial question due to the volume of used EV batteries, which will come on the market for energy storage stationary application. I think, Beat, you would be the right person, I think, for the second life side.
Yeah, I can answer that. I mean, the standard itself doesn't say anything about whether it should be new batteries or, let's say, second life batteries, which basically means you can use second life batteries. There is, of course, still a gap with regards to how to evaluate or assess second life batteries, but also there the IEC is working on standardization. What is clear is what I think we can already say clearly is second life batteries need to have a history. So you need to know exactly how those batteries have been treated in their previous life. And that basically only goes via that data collection, which also, of course, makes it maybe a bit challenging. Because eventually not everybody is, let's say, collecting those data. But without having a history of the battery, it will be difficult, for example, to assess an energy storage system which consists of second life batteries. I guess I can already say that. Also, again, the standard doesn't say anything about second life or first life or whatsoever. It needs to be safe. The focus is on safety.
So the let's say there is a UL standard on the treatment of second life for ESS.
There is a UL standard, but that's more like a process standard. But within the IEC, the technical committee, there is work ongoing on how to be able to validate second life batteries. So there will be IEC standards published probably within the next, I would say, 2 years. Maybe Maarten knows a bit more about that. I think he is also a member of that committee.
I don't know if you know that, Maarten.
You have to repeat a little bit the question for me because the sound was a little bit poor.
So it was about the, have you been involved with the second life contribution of batteries, also in the respect of standards?
No, not directly in the second life of batteries. No, there are some. I have some contacts with parties who are in this field, but from Koolen Industries' perspective, we do not have any plans yet for a second use of batteries.
Okay. Despite there's a, let's say, a huge volume coming back on the market, which is, let's say, in times it's difficult to access new cells and new modules. Reuse of modules can be a perfect opportunity, right?
Correct. Yes. Especially from the automotive market, of course, where still a battery is seen to be at the end of life when 80% state of health is reached, but there's still 80% left. So this could still be used very well. And my guess would be that the challenge for manufacturers of battery energy storage systems with these batteries is to guarantee an optimum lifetime, let's say, as it's very difficult to see how the battery has been treated in its life. Some aspects you cannot not easily trace back.
Okay, thank you.
Yeah, Maarten, of course, you made a very good point, and sorry if I quickly interrupt, but that's exactly where the standardization is working on. That you actually have a history of the battery, so that at any point in time, batteries which are coming out of cars in particular, that you can see at any point in time whether the battery has been exposed to extensive vibration, whether it has been overcharged, whether it has been overheated. Because yes, when you have had this kind of event occurring during the lifetime of a battery, then you can no longer really guarantee the safety. Right?
No, and what the impact on our side is that our estimation for the state of health becomes more and more critical, and many aspects has to be taken in account. As you say, elevated temperatures and do have their effect on the state of health. So the way it's being measured and calculated is a very critical aspect of our systems. Another short question I would like to ask, maybe you also know, Beat, is the new battery regulation, which is at the moment being put on hold. But instead of a directive, it has become a regulation. How do you see the possibility for a standard like 62933 to be harmonized in the near future?
It is likely. I mean, there is this standardization, let's say the European Union standardization mandate towards CENELEC for the new battery regulation, and 62933 actually has been added there as a standard of. So there is certainly something going to happen with that regards. And I would not be surprised if that actually at some point in time would be added. From a regulatory perspective, the only place where such a standard like 62933 could fall under indeed is most likely the battery directive, because it doesn't really fall under the low voltage, or not always. Of course, any kind of energy storage system is covered by the EMC directive. That's clear. There is no reason why not. But it will be difficult to put this under, let's say, the low voltage directive. So the most reasonable place is that battery regulation.
Yes. Okay. Thank you.
Okay. We have, let's say, 1 minute to go, and we have one question, which I don't know if it's easy to respond, but I will read it for you. I think for Henk or Beat. Does this standard include the specific battery cycles that can be applied on ESS systems in order to acquire the performance of the whole setup? Maybe this goes already too far for now, but can you say something about it?
Yeah, I can give a general answer. Like mentioned in the presentation, there is in the 62933 series, there is also part 2-1. And in that standard, you actually see what unit parameters are specified for a product like a storage system. And this standard also describes clearly the methods how to determine the different parameters. And it's talking about nominal energy capacity, the round trip efficiency, the input and output ratings, the system response time, etc. So most likely you can find the answer in this specific standard.
Okay. Thank you, Henk. Thank you, Maarten. Thank you, Beat. I want to thank the participants for this webinar who showed up and to listen to us. Just one last request, and that is to rank our webinar so we can learn from it at the end. And you can also do that from the Klaxoon platform by using the access code or the link in the chat. By this, I want to conclude this webinar for today. Thank you all. Wishing you a nice evening. Bye-bye.